Hello and welcome to this tutorial. My name is Mehdi, and in this tutorial I'm going to show you how to create freezing or frosting effect inside the Houdini. This tutorial is based on a request from one of my friends, and I'm sure that there are more than one way to create this effect. However, in this tutorial I'm going to show you one of the simplest methods for creating this effect. So let's start with the simple scene, and in this case I'm going to use a grid and apply this effect along this grid, which is a flat surface. And let's create a scatter node, and let's disable the relax iterations option. In this way, as you can see, we have more random points on the surface of the grid. And also let's create a sphere, and let's move it to one side of the grid, and let's attach an eyes offset node to the sphere and the color node to make it red, and let's create a point node to create color attribute for the points and make all of them black. And also we need a solver node. Here. Let's connect the points to the first input and the sphere to the second input. And inside the solver node, let's create an attribute transfer node, and let's transfer the color attribute from the sphere to the points. And here I'm going to create a switch node to switch between the previous frame result and the first input result. And as the condition, let's type $f is greater than 1. And let's choose the input 1 as the first input, and here let's select color as the attribute and reduce the distance threshold and increase the blend width. Let's go back and let's create a simple animation for this sphere. Let's move it from this side to other side in 100 frames. And here you can see we can identify the path of the effect with the help of a solver node. Okay, and here let's create another sphere node, and also create a copy node and copy the sphere into the points. Let's reduce the uniform scale value, and of course we can create an attribute for the scatter point. An attribute like ID, and it's equal to the point number, and here I can randomize the radius of the spheres with the help of this attribute. And also let's enable the stamp option, and let's create a variable for the color attribute. Let's name it pt red, and this is equal to $color rate. And let's use stamp expression here. Copy one, pt red, and 0 as the default value. And as you can see here, we have some kind of growth animation for the spheres. Also, let's create a delete node, and let's delete the points which have a color red value less than 0.1, or oh, that's okay, 0.1. And here let's create another delete node and delete some points based on the ID attribute. And as the expression, let's type random $ID is less than 0.9 or 95. Okay, and here let's delete the black points. $CR is equal to 0. Okay, and here I want to copy a geometry into these points. I want to create something like icicle shape and copy the icicle geometry into these points. So let's create a line, and let's increase the length attribute, the length value, and here let's create a resample node, and let's choose maximum segments, and 10 is a good value. And here let's group the points here, the points which have a point number greater than 0, and apply a jitter node to this group. Let's rename it to jitter. Let's select this group, and let's decrease the scale value. Okay, and also I want to create a width attribute, and I want to start from a specific number and end with a number near to 0 at the end of the line. So let's create an attribute, create node, and here let me create a parameter for the initial value for the width, and let's name it, for example, width, something like that. And here let's create a width. Let's create width attribute, and as the value, let's type channel width minus $PT multiplied by channel width divided by endpoints, the point number of the resample node. Okay, and now let's connect it to a polywire node to see the result, and choose attribute, to choose width attribute, and here let's increase the width. As you can see here, the icicle starts with the 0.3 for the width and ends with the value here to 0. And here let's copy this geometry into the selected points. So let's create a copy node, and let's see the result. And of course you have to create a carve node just after the resample node to create the growth animation for this icicle. And also this parameter will be based on the color red attribute of the points. So let's go to the stamp and enable the stamp inputs, and also create a variable same as before, PT red, and the value is color red. And also let's use the stamp expression here, copy to PT red and 0 as the default value. Okay, and also we have to randomize the length of the line. So let's create another variable here, for example PT rand, and this value is going to be the ID attribute multiplied by actually let me create a random value based on this ID attribute, and this is going to be stamp copy to tt rand and 0. Okay, let's create two. Let's add a random value here. And also we can create a transform node. Here and rotate them randomly along the z-axis or x-axis. So let's copy this stamp expression and paste it here and multiply it by a number, and in this case I think 20 is a good value. And also let's rotate them along the z axis, and here let's create a random value based on the previous generated random numbers. So in this way we can have a random number, we can have a different number from the x value of the rotation parameter. So that's good, and of course we can multiply it by 2, and let's type -1 here to generate a random number between -1 and 1. Okay, let's decrease this number to 10. And I think that's good for this tutorial, and what we can do here is to merge the result of these copy nodes. Okay, you can see their animation. And now we have to convert this shape to the VDB. Sorry, let's create a VDB from polygon. And we have to convert it back again to polygon. And you can increase the adaptivity parameter for decreasing the number of segments. You can see we have a little bit issues here. What you can do is either to delete these small pieces, or you can go and decrease the voxel size. I think 8 is good. What else you can do is to increase the width parameter 0.5 or maybe 4. And if you want, you can keep these icicles here, or you can go and here let's add a number to this pt random, or simply you can go and disable the prevent joint buckling. It's up to you. And here is the effect along a simple path. Okay, here is the final result. I just saved the geometries into the files for the faster feedbacks, so you can see we have a nice animation and nice effect here. What you can do is to apply this effect to different surface shape. For example, let's create a tube and let's select the z-axis for the orientation, and let's increase the radius and the height of the tube. And here what I can do is select the polygon as the primitive type, and here if I go to the top of the network and let's apply the scatter node to this tube, and also instead of using this sphere, instead of using this sphere, actually let's delete the animation and let's increase its size along the z-axis and move it here. And let's create a curve node connected to the tube. And let's choose the mesh type, and here if I go to the wireframe mode and select the display point numbers. You can see this point number 26. It moves along this surface and this circle, and what I can do is create an animation. For example, increase it from 0 to 1 in 100 frames. And let's delete all the points, but keep the point number 26. And here let's copy this sphere to this point, and let's move it to the center, and here, as you can see, it follows the animation. And let's connect it to the second input of the solver. Let's see the result of the solver. Okay, I think we have to increase the radius of the sphere. Or move it maybe a little bit along the z-axis. Okay, to cover all the points. And here, let's see the final result here. As you can see here, the first problem is the orientation of the icicles. So we have to create the normal attributes for the points. Here, just before the scatter node, let's create a facet node, and let's choose post compute normals. And here now you can see we have the normal for the points. Let's see the result again. And of course here we have to rotate this icicle minus 90 degrees along the x-axis. Okay, as you can see, we have the right orientation now. Also here, let me pause the video and save the simulation to the disk. Okay, here is the result, and as you can see, also in this case we have very good simulation and interesting animation. And as I've said before, I'm sure that there are many ways for doing this effect and creating this effect. For example, about the animation that you saw at the beginning of this tutorial, I've used different methods, and as you can see here, I've created an asset out of this method, and you can see there are various parameters that you can change and have control over the growth of the eyes. And here I've used the combination of this method and another method that I explain in this tutorial, Houdini AI animation. I just copied the icicle growth animation to the points, and also the other advantage of this method is that we don't have any animation for this sphere as the starting point. So here I can choose just the starting point, just the starting point of a surface, and here this solver runs the simulation, and finally it covers the surface with the ice and the icicles. But anyway, also the previous method is simple and effective, and if you are interested, you can go to my website VFXHOMELAND.com and take a look at different tutorials, and also you can please also follow the free tutorials. I'll update it frequently and as much as I can. So I hope you enjoyed this tutorial, and I hope to see you in the next tutorial.